can this thing actually fly? Is there a real-life flyable Darkstar out there somewhere?
Sam, with movie magic, this can fly.
Okay.
But in the real world, this is a mock-up of our hypersonic airplane concept for the Top Gun movie.
How fast could the SR-71 go? It could literally go from Washington, D.C. to Los Angeles in under an hour. And that's 2,193 miles per hour in recorded flight.
The wait is finally over. The U.S. has officially revealed the SR-72 Darkstar, the highly awaited successor to the iconic SR-71 Blackbird. After years of wait and speculation, the details about this hypersonic drone have come to light. And they're even more impressive than expected. Built for incredible speed, stealth, and advanced capabilities, the SR-72 is set to redefine military aviation. But can it truly surpass the legacy of its legendary predecessor? Let's see the game-changing features of the SR-72. Can it outshine the legend it's meant to replace? The legendary Blackbird. If you ask anyone to name a historic U.S. military aircraft, chances are the SR-71 Blackbird comes up at the top of the list. This incredible piece of engineering wasn't just a plane, it was a symbol of speed, stealth, and power. But why was the Blackbird so legendary? Let's rewind a little. Back in the 1960s, during the Cold War, gathering intelligence was crucial, and spy planes like the U-2 Dragon Lady played a vital role. But things changed in 1960 when Gary Power's U-2 was shot down by a Soviet missile, revealing a massive vulnerability in the U.S. spy capabilities. The need for something faster and stealthier became urgent. That's where Lockheed's Skunk Works team stepped in with the SR-71 Blackbird, which first flew in 1966. Capable of speeds over Mach 3.2, about 2,200 miles per hour, it cruised at altitudes over 85,000 feet, so high that it could outfly enemy missiles. This aircraft wasn't just fast, it was nearly untouchable. Its design to reduce radar detection, an early form of stealth technology, made it even more fascinating. With its sleek, otherworldly appearance and titanium frame, it could take on missions no other plane could. The Blackbird dodged over 4,000 missiles during its service, all while gathering vital intelligence from hotspots like Vietnam, the Middle East, and even the Soviet Union. Imagine flying over enemy territory, knowing you could outrun any threat. That was the Blackbird's world. This jet set records for speed and altitude and held them for decades. One of the most impressive, flying from Los Angeles to Washington, D.C. in just 64 minutes, a record that still stands today. The SR-71 was more than a fast plane. It symbolized the U.S. sense of technological superiority during the Cold War. It represented a time when innovation was pushed to its limits, and in many ways, the Blackbird became a cultural icon. But here's a question. Could anything surpass the Blackbird's incredible legacy? Replacement of SR-71. If I say that no matter how impressive, consequential, or unstoppable something seems, everything eventually has its downfall, you would agree. The Blackbird became more vulnerable as radar and missile technologies advanced throughout the 1980s. Though it could outrun most threats, radar systems had evolved to the point where tracking it was easier. And missiles, they were getting smarter and faster. On top of this, the cost of operating the SR-71 was skyrocketing. Each flight hour was around $85,000, making it an expensive asset to maintain. By 1989, the U.S. government faced a difficult decision: retire the Blackbird. For many in the military, this was a tough pill to swallow. The Blackbird had proven invaluable in gathering critical intelligence for decades, often flying deep into hostile territory where no other plane could go. However, soaring operational costs and improved satellite exploration meant it was time to move on. However, retiring the SR-71 left a gaping hole in the U.S. military's intelligence-gathering capabilities. Nothing could match its speed, altitude, or stealth. The burning question became, what could replace the fastest, stealthiest plane ever built? Another reason? The development of a dual-mode ramjet engine can handle both subsonic and hypersonic speeds. This would allow the SR-72 to fly faster than any aircraft ever built. But with all the secrecy surrounding the project, many wondered, is the SR-72 really the next step in aerial dominance? Or just another expensive gamble? And what could be so revolutionary about this new plane? the birth of the SR-72 Darkstar. The SR-72 Darkstar, often called the son of Blackbird, isn't just an upgrade. It's a whole new breed of aircraft. Imagine a drone flying at Mach 6, twice the speed of the SR-71 Blackbird. That's over 4,600 miles per hour. This isn't sci-fi, it's real cutting-edge military tech in the making. But how do you even build something that fast? The secret lies in the engine. Skunk Works engineers partnered with Aerojet Rocketdyne to create a dual-mode ramjet engine. Unlike traditional engines, which are limited to subsonic speeds, this can handle both subsonic and hypersonic flight. It works like two engines in one. When the SR-72 takes off, it operates like a regular jet, but once it hits supersonic speeds, the ramjet engine kicks in, allowing it to accelerate to Mach 6. It's like a switch between cruising speed and hyperspeed. The technology behind this is mind-blowing. Ramjets work by compressing air at high speeds. Still, the SR-72's engine takes it further by adding a scramjet, supersonic combustion ramjet, which enables the aircraft to handle hypersonic speeds without overheating or falling apart due to extreme pressure. This dual-mode capability is a giant leap forward in aviation technology and could be the key to making the SR-72 the ultimate surveillance tool. Replacing the CR-71 means the need for more advanced speed and intelligence technology. By flying at Mach 6, the SR-72 could outrun any missile aimed at it. Enemy radar wouldn't even have time to track it before it's gone. It could gather intelligence, take high-resolution photos, or even launch hypersonic missiles before disappearing from enemy airspace without a trace. Amazing, right? This isn't just a fast drone, it's a game-changer for military operations. Could this engine be what makes the SR-72 the future of spy planes? Only time will tell, but it's clear that the SR-72 is set to revolutionize aerial reconnaissance. Speed is the new stealth. In the aeronautical world, speed is more than just an advantage. It's a form of stealth. The faster you move, the harder it is to catch you, and that's precisely the concept behind the SR-72 Darkstar. At Mach 6, over 4,600 miles per hour, this hypersonic drone is designed to gather intelligent information and leave enemy airspace long before anyone can react. It's practically a ghost in the sky, making traditional radar systems and even surface-to-air missiles look outdated. But with this kind of speed comes some severe challenges. Moving at Mach 6 means dealing with extreme heat. The friction generated as the SR-72 slices through the air at such high speeds causes temperatures to rise to more than 3,000 degrees Fahrenheit. To put that in perspective, that's hotter than the melting point of most metals used in aircraft today. So how do you keep a machine intact while traveling at such extreme speeds? This is where the engineers at Lockheed Martin's Skunk Works pushed the boundaries. They had to develop advanced materials that could withstand the intense heat and maintain the drone's stealth capabilities. The solution? A mix of carbon composites, ceramics, and specialized metals. These materials are designed to hold up under intense pressure and heat while remaining light enough for the drone to maintain its incredible speed. Carbon ceramics in particular play a crucial role. They are both lightweight and capable of withstanding high temperatures, making them ideal for hypersonic aircraft like the SR-72. These materials act as a protective shield, preventing the plane from melting or losing its aerodynamic shape mid-flight. But that's not all. These materials also help reduce the drone's radar signature, making it harder for enemies to detect. So not only is the SR-72 fast, but it's also stealthy, thanks to the very materials that keep it from burning up. This balance between speed and stealth makes the SR-72 such a revolutionary aircraft. It's designed to zip through enemy airspace, gather critical data, and be gone before anyone even knows it was there. And if missiles are launched, good luck. By the time they're in the air, the SR-72 will be long gone. But here's the kicker. While speed might be the new stealth, the combination of advanced materials and engineering makes the SR-72 a marvel. It's not just about going fast, it's about surviving those speeds and staying invisible simultaneously. Now, with such advanced technology, what other possibilities does the future hold for hypersonic aircraft? The hypersonic arms race. In recent years, military competition has shifted into a new frontier, the hypersonic arms race. Russia and China have been making significant strides in developing hypersonic missiles that can travel at insane speeds. and strike targets with almost no warning. The US had to respond, and that's where the SR-72 comes in. This aircraft isn't just about gathering intelligence anymore. It's about ensuring the US stays ahead in this global race. Imagine this, the SR-72 flying at Mach 6, already faster than anything out there, equipped with hypersonic missiles of its own. It's almost mind-boggling to think of a hypersonic drone firing off even faster hypersonic missiles. But that's precisely what's on the horizon. In 2018, Lockheed Martin confirmed that the SR-72 would have the capability to carry and launch these missiles. But here's where things get tricky. Hypersonic technology is costly. Developing something as advanced as the SR-72, with its specialized engines, materials, and missile systems, requires massive funding. The US military is no stranger to big budgets, but the question remains, can they afford to develop and maintain such a powerful aircraft? Historically, maintaining advanced aircraft like the SR-71 Blackbird was a costly endeavor, with each flight costing tens of thousands of dollars. The SR-72, with all its hypersonic features, won't be any cheaper. Some estimates suggest that building a prototype could cost nearly $1 billion. While the military budget for cutting-edge technologies is large, there are always trade-offs, and this project may face scrutiny. The other factor to consider is the pace of global competition. As the US works on the SR-72, Russia and China are also ramping up their own hypersonic weapons programs. It's not just about having the most advanced drone, it's about staying ahead of adversaries developing similar capabilities. The SR-72 could be crucial in maintaining US military dominance in a world where speed is becoming the key to offense and defense. Ultimately, the SR-72 isn't just a futuristic aircraft. It's a strategic response to a rapidly evolving global arms race. The real challenge will be developing this incredible technology and ensuring that it's deployed effectively without breaking the bank. Can the US military afford to build and maintain such a powerful aircraft? The future of hypersonic flight. The future of aerial warfare is about speed, and the SR-72 Darkstar is at the forefront of that revolution. The first test flight for this hypersonic drone is expected as soon as 2025, and we hope it will enter service by 2030. If all goes according to plan, the SR-72 will become crucial to modern military strategy. But it's not the only piece of the puzzle. The US is also working on advanced technologies like the B-21 Raider bombers and other hypersonic vehicles. The SR-72's role, however, is unique. It's designed to be faster than anything we've ever seen, and its ability to gather intelligence and possibly even launch hypersonic missiles would give the US a significant advantage in future conflicts. Hypersonic flight isn't just about speed, it's about outpacing any missile defense system. When moving at Mach 6, no missile can catch you, and no radar can track you for long. That's the game-changing part. But with such bold promises come tough questions. Will the SR-72 Darkstar live up to the hype? Developing hypersonic technology is a small feat, and projects like this often need more time, budget overruns, or technical setbacks. The SR-71 Blackbird was ahead of its time, but came with massive operational costs. Will the SR-72 face similar challenges? Can it deliver on the promise of being a hypersonic drone that is both powerful and affordable for the US military? While Lockheed Martin has been making steady progress, some experts wonder if the SR-72 will genuinely be able to fulfill its ambitious goals. In a world where new technologies are emerging rapidly, it's a race to see which country can perfect hypersonic flight first. Russia and China are just a little behind with their hypersonic programs. The US must stay caught up in this new arms race, which puts immense pressure on the SR-72 project. Still, if the SR-72 can do what it's supposed to, it won't just be a tool for reconnaissance. It could change the very nature of aerial warfare. Hypersonic flight could open the door to missions and capabilities we can't fully predict. From intelligence gathering to launching strikes, the SR-72 has the potential to be a game-changer. So while the future of hypersonic flight holds much promise, it also raises significant questions. Can the SR-72 Darkstar meet these lofty expectations? Or will it become another costly military project that fails to deliver on its big promises? We'll have to wait and see. The role of technology in the SR-72's development. Technology plays a massive role in making the SR-72 Darkstar possible. One of the most important breakthroughs that helped bring this aircraft to life is additive manufacturing, or 3D printing. What's so special about this? Lockheed Martin's engineers are using 3D printing to create parts that would have been nearly impossible to make just a decade ago. For instance, components like the engine's cooling system and parts of the aircraft's structure rely heavily on 3D printed materials. The cooling system is particularly crucial for a hypersonic aircraft like the SR-72. At Mach 6 speeds, the heat generated is so extreme that regular metals and materials would either warp or melt. With 3D printing, engineers can design highly specialized parts that withstand the heat and keep the aircraft lightweight and efficient. This kind of manufacturing has made it possible to bring complex designs to life in a way that traditional methods couldn't match. The SR-72's structural elements also benefit from this technology. High-performance materials such as carbon composites and advanced metals are layered together with precision, creating a frame that can handle the stress of hypersonic speeds without falling apart. In the past, producing such parts would have taken years and might not have been feasible, but additive manufacturing has sped up the process and allowed for more intricate, heat-resistant designs. But here's where it gets even more enjoyable. 3D printing isn't the only technological leap making the SR-72 a reality. Innovations in computer modeling and simulation have also been crucial. Engineers can now test how different materials and parts will perform under hypersonic conditions long before they're built. This virtual testing reduces the risks of such an ambitious project and allows for faster iteration. They can simulate heat, stress, and other forces acting on the aircraft, refining the design before a prototype is made. So the big question is, what other advanced technologies are still under wraps? We know that hypersonic flight is just the beginning. With tech like 3D printing and simulation, the possibilities for the next generation of aircraft are limitless. Imagine what else could be on the horizon for aviation. A future where planes fly faster, longer, and further than ever before, all while being more efficient and more challenging to detect. What's next? That's the exciting part. And with the SR-72 leading the way, we might be closer to finding out than we think. The SR-72's role in the future of warfare. The SR-72 Darkstar is more than just a fast drone. It offers a preview of what the future of warfare could look like. Imagine a battlefield where hypersonic drones like the SR-72, along with hypersonic missiles, dominate the skies. These machines move at such incredible speeds that they can gather intelligence and strike targets before anyone has time to react. The SR-72's speed and stealth will make it nearly impossible to detect or intercept, giving it a massive advantage in modern combat scenarios. In future wars, speed will be the deciding factor. While traditional aircraft and even today's advanced jets rely on stealth technology and maneuverability, hypersonic drones will operate on a different level. With the ability to fly at Mach 6, the SR-72 can enter hostile airspace, complete its mission, and exit before enemy defenses can respond. That's not just a technological leap, it's a complete game changer in how wars are fought and won. But it's not just about speed. The SR-72 will also be a crucial tool for gathering intelligence quickly. Real-time data on enemy movements and capabilities is critical in modern warfare's fast-paced environment. A hypersonic drone, like the SR-72, can sweep over enemy territory, gather high-quality data, and deliver it back to military commanders in seconds. That means decisions can be made faster and responses can be more precise, reducing the risk of collateral damage. There's also the potential for the SR-72 to be armed with hypersonic missiles. Picture this, a hypersonic drone flying at Mach 6, launching even faster missiles at targets on the ground or in the air. The enemy wouldn't even know what hit them. It's a new era of warfare where the ability to strike quickly and accurately from long distances becomes the ultimate advantage. The SR-72 is just the beginning of what's to come in military aviation. As technology advances, we'll likely see more hypersonic drones, faster and more efficient aircraft, and even more sophisticated weaponry. The skies will no longer be the limit. They'll be a key battleground where speed and stealth are the most valuable weapons. In the end, the SR-72 represents a huge leap forward in our understanding of aerial combat. It's not just a fast drone, It's a symbol of what's possible when cutting-edge technology meets military strategy. The future of warfare is moving at speeds we've never seen before, and the SR-72 is leading the way. So there you have it, the SR-72 Darkstar, a plane that could redefine what's possible in aviation. With speeds reaching Mach 6, the ability to fire hypersonic missiles, and cutting-edge technology, this drone is set to be the future of aerial reconnaissance and warfare. But now we want to hear from you. Do you think the SR-72 will live up to its promise? Or is it just another overhyped project? Let us know in the comments below, and remember to like, share, and subscribe. See you next time.